Hello, and welcome to my platform tutorial in XNA. Today we're going to cover setup and basic movement for creating a platform game from scratch. So let's get started. First thing you want to do is create a new project. Have experience with, if you want to just port this right to 360, you can. I'm not going to do that because my 360 is the red ring of death. I'm not going to go into that. So just create a new Windows game, aim it right at the platform, and we're just going to make a platform tutorial. Okay. It'll take a while. Okay, and this should come on. Next thing you're going to want to do is import your pictures that you hopefully downloaded from my site. Do add existing item, and then find the pictures. You could also just drag them in. Okay, so you shouldn't have to rename these. So next thing you're going to want to do is create your textures. So texture 2D, BG for background. And then texture 2D, Lucas, texture. Okay, now you're going to need to load your content. For people who've already done XNA, this is just basic stuff. It's kind of boring to do. Just do bg equals this dot content load texture 2D stage. You don't need to put the extension because it renames it to whatever the regular name of the file is without the extension. And do Lucas texture equals this dot content dot load. And then Lucas. Okay. So after that, if you play it, still the blank screen because we didn't draw anything yet. So next thing we're going to do is draw the background and Lucas. So it already created a sprite batch for us, so we just want to sprite batch dot begin. Okay, sprite batch dot begin, and then next thing you're going to want to do is do a sprite batch dot draw. Just draw the background. You don't need to use a rectangle, just do new vector 2 0 0 and then color it out white, which doesn't change any of the colors. You're going to need to add a new variable up here. Call it source bounds, src bounds. Make it a rectangle. Equals new rectangle 0 0, the width of one sprite, and then the height of one sprite in the sprite sheet. So what source bounds is going to do is determine which frame of the sprite sheet right now the top left frame is showing, which is him just standing. It's not even animated right now. And then create another rectangle above that called Lucas bounds, which is his actual boundaries, the actual character boundaries. Similar to a controls boundary. And that is going to be it's 57,377. Width is 40. Height is 48. So down here you're going to want to do spritebatch.draw Lucas texture, Lucas bounds. Ignore the color, we're using something different, so then do source bounds and then color it out white. Okay, so if you play that, I didn't end it. Crap. Man, I always forget to do that. Yeah, so if you don't end the sprite batch, it's gonna give you massive error. Sprite batch.end has to be there. Okay. Yeah, he's okay. This is really just get some check. So it's 337. How do I know that? I actually went into Paint and checked exactly where he should be in relation to the ground. Later on, when we do collision, this is going to become less important because you can just spawn him up in the top left corner, and then he could just fall down and hit the ground. But for now, we're just doing basically one, so we're not doing collision. I don't have to deal with that. So, next thing you're going to want to do is add in a direction variable. Let's do string direction. I use directions a lot. So, I mean, I use string direction variables a lot. Maybe this is a bad habit. But just seems to keep the code a lot more organized. I mean, you know what's going on in the code, even though it might not be organized. So string direction equals stand, because that's what he's doing, is standing. And then string facing equals right. So that's the direction he's facing. So right now he's facing right, and we're gonna have it flip if he's facing left. Actually, I could just do it right now. Down here, go back to the draw event. Do if facing equals right, or equals right. Then the regular spritebatch.draw. Else, if it's facing left, we're gonna have to flip it. So copy. Don't even copy that. Do spritebatch.draw Lucas texture. Lucas bounds, source bounds, color that white, 0f, new vector 2, 0, 0, and then sprite effects. See, I'm making all these null because we're not really. I guess I could just put null, but I never really did that, so I'm not going to try it. Do sprite effects dot flip horizontally. So what that is going to do is flip it horizontally, basically. Regardless of, like in VB, we had to manually flip it and change all the algorithms around when we wanted to animate the texture, because we were flipping the texture, and then we had to make the source bounds equal to where the frame would be on a flipped texture. But here, it's flipping whatever texture is used by by source bounds. So it'll take that frame and it'll flip that individual frame rather than flipping the whole texture and changing the outcome. So yeah. So that's 0F. And it looks really long. I guess I should go like, just to make it look a little shorter. You can. Okay, so that's the basic draw event. We shouldn't have to do anything else there. If you change facing to left now, you should notice that he faces left. If he doesn't, then you should go back in the video and figure out what you wrote wrong or what you did wrong. So now we're going to do the direction code. So in the update method right here, we don't want to clutter this up too much, so we're going to create another method, just a null method. Lucas move. This generate method stuff. Alright, now within this method, first we'll switch direction. Direction can equal a number of things. Case stand, first of all, and break. Case left, then break. Case right, break, and case up. We're not going to be doing jumps today, but we'll just add that in so it's there later on. For the stand, actually, what you're going to want to do right now is go up to the top, create a variable, an integer variable called frame count, set it equal to 0. So what this is doing is it's a basic counting variable. It's counting which frame is in the source bounds, which frame is currently in the source bounds. So, and we need to use this to loop. So, if we want to, like, suppose we have 4 frames, but we want to loop them. Once frame count equals 4, we'll reset it to 0, and then it will continue looping, which is exactly what we're going to do right now. So in Lucas move after stand, actually after the entire switch, do frame count ++, so that just adds 1 to frame count, so it's like basic counting variable, it's going to count up. And if it's stand, do frame count equals 4, then frame count equals 0. Excuse me. So that's just going to loop it, and now we're going to have to set the source bounds equal to new rectangle, and it's going to have to be it's going to have to incorporate frame count. So we'll do frame count times whatever the width is, so it's 40 in this case, 0. When we change the y variable, this means we're changing, in this particular sprite sheet, it means which kind of sprite we want. Right now we're using the standing animation, but if you would change this to 48, it would go down to the running animation. If you would change it to 96, it would go down to the jumping frames. So right now we just want it at 0 at the top, for width 40, for height 48. So yeah, that should do right now. If you play it, you'll notice he's moving way too fast. way too fast. So we're going to need to create something to slow him down. So this is the next step. Go up to the top, create a constant integer called delay, set it equal to 4. So what this is going to do is ensure that the code only runs the switch variable, the switch direction, and changes the frame every 4 times it runs through the update code. So if we go down, in order to accomplish this, we're going to need to change some things around. First of all, we're going to have to wrap the entire switch in an if statement. Let's do if frame count mod, which is the percentage sign, shift 5, frame count mod delay equals 0. So basically, if frame count is a multiple of 4, so it'll do this once every 4 times, then it's going to do this. But instead of frame count equal 4, it's going to have to be frame count divided by delay equals 4. So frame count equals 16. Then it would equal 4 divided by delay. And we're also going to need to change this to do frame count divided by delay times 40. You can actually create a new variable instead of doing that. So in between frame count mod delay equals 0, just create an integer called frame, and set it equal to frame count divided by delay. So then you can just delete frame. But then you have to make sure that you're not setting frame equals 0, you're actually setting frame count equal to 0. Because frame doesn't really do anything outside of this if statement. So then change that to frame too. And now if you play it, oh crap, hold on. Okay, yeah. Alright, maybe I was wrong in using frame. That was probably a bad idea. Let me see if it... Hold on a second. Alright, yeah, I don't know what's wrong with this, so just delete frame. And switch it out for frame count divided by delay. Yeah, so now he's moving a lot slower than he was before. And you should notice if you change the facing to left, he'll actually move as well. So the next thing we're going to have to do is controls. Before we can go on to moving left or right, we're going to have to accept controls. For this tutorial, I will probably I'll cover both keyboard and gamepad, but I'm just going to use gamepad. So yeah, if you want to use the keyboard, it's keyboard state, key state equals keyboard dot get state. That just gets the current state of the keyboard, sets it equal to key state. So then you can use key state for all your variables of key state dot is key down keys dot d. I'm going to use WASD instead of the arrow keys. If key state dot is key down keys dot d. Oh crap. Direction equals right, because he's moving to the right, and facing equals, oh wait, facing equals right. And then you can just copy that, paste it, change keys.d to keys.a, change direction, and facing equal to left instead of right. And then do the same thing for, you can delete facing, set the direction equal to up, and do is key down keys.w. We're not going to be dealing with that today, so don't really worry about that. I'm just going to put it there right now. And then for the key up events, if you can just paste again, if key state dot is key dot down, and change it to is key up, keys dot d, and direction equals right. This actually gets rid of a bug by doing and direction equals right that I had earlier. If the character is moving to the right and he holds down the left key, telling the computer he wants to move to the left, if he then depresses the right key, it's going to run the key up code. Had I not had this and direction equals right, it's going to run the key up code for the keys.d, and then the character is going to stop while he's moving left. So I didn't want that to happen, so you have to do and direction equals right. You want to ensure that the player is moving in the same direction that he's stopping in, so he doesn't start moving left and then suddenly stop standing to the right. It's just not right. So copy that, paste it, change it to A, once again changing all the rights to lefts. Just do a quick replace. Okay. And we're not going to worry about the up key right now. So you want to change direction equal to stand here, and you can keep the facing like that. That's okay. So next thing we're going to have to do, I'll tell you, this is if you want to use a keyboard and you don't have a controller. Since I have a controller, I'm just going to use that. So just comment that part out. If you're using a controller, the gamepad's already declared for you. So just do if gamepad dot get state player index dot one dot thumbsticks dot left dot x, it's a mouthful, is less than 0 or greater than 0 first. Then the character's moving right. Well, you're telling the character to move right. So then direction equals right, facing equals right. This is actually a lot simpler than using the keyboard. Face equals left, direction equals left. And all you have to do here is change the .x is greater than to a .x is less than 0, which means moving to the left. And then paste that again. Change the... don't worry about facing, delete that. Change the direction equal to stand. And this is if x equals 0, which means the person isn't doing anything. He's not moving right or left. So that should be good for right now. Now we're going to need to write the code for left and right. So I'm going to take a quick break right now and I'll come right back. So welcome back. Um, so what we just accomplished is basic standing animation using delay and a frame count, animating a sprite sheet, and flipping the image. So what we're going to have to do now is make the character move to the left and right. We already put the controls in to move to the left and right using either the gamepad or the keyboard, whichever one you want to use. So we're going to need to declare a new variable, this time a float, call it speed. This is the character's speed. Set it equal to 0f right now. Go down to the case for the right. So right now, we're going to need to change the speed of the character. So if the character is moving right, he's going to be moving in a positive direction. But we don't want him to go too fast. So we're going to encase this in an if statement. So if speed is less than, actually go up to the top now and create a constant float called max speed and set it equal to 12f. This is just the maximum speed. This is how high it's going to go. So if you want to change it, you can just go up to the top there and change it. If speed is less than max speed, if it's less than max speed, then we're going to be able to add 1. So plus equals 1. So that's going to move the speed to move the character to the right. Right now it's only adding 1 to speed, but by putting in Lucas bounds dot x plus equals speed, we effectively move the character in the direction speed is. So speed can actually be negative in the case of moving to the left. Speed will go negative, so we still add it to the x value of the character, because since it's negative, it's actually subtracting it. When you add a negative number, it subtracts, so it's pretty basic math. So next thing you're going to do is copy the source bounds code for stand and paste it. We're actually going to use the next frame down, so change the y value to 48. You don't need to change anything else, only copy the if frame count divided by delay equals 4. Paste that in as well, and change 4 to 8, since there's 8 frames instead of 4 frames in this particular animation. Okay, if you follow me. So you can copy all that and then paste it to the left, but instead of adding 1 to speed, you're going to be subtracting 1, and you're going to want it to be greater than negative max speed, which should be negative 12. So it'll go all the way down to negative 12. We don't need to change anything here. We don't need to flip the image or anything, because that's done by post-processing. I guess that's what it's called. So yeah. So don't do anything for case up yet. You can play it, although, yeah, that's what I thought. You gotta cast the speed as an integer. In VB, I just used speed as the integer in the first place, but in XNA, when you want to move it to the left or right in midair, when we get to the next tutorial, it's kind of hard to deal with that in an integer variable. It's much easier to deal with it in a float. So you'll notice he moves to the right and left. He just disappeared. This is because I always forget to do this. Alright, you'll notice he disappeared. That's because when it was set back to, when the direction was set back to stand, instead of equaling 4, it was greater than 4. So frame count just kept adding, and it was equaling a non-existent frame. So we don't want that. So we want to do greater than or equal to 4. So it resets frame count to 0 if it's greater than 4. And do the same for left and right. So now if you use your controller or your keyboard, whichever one, yeah, he'll move left and right like he's supposed to. Don't worry that when you stop it and then you move left or something, he kind of like moves in the opposite direction for a little bit. We're going to fix that right now. So in order to fix that, it's because when he's standing, nothing's happening to the speed variable, so it's remaining negative or it's remaining positive, and then when you switch to an opposite direction, he's still going in that same speed for a while until it passes 0. So we're going to want to equalize this to 0 when he's standing, but instead of just making the speed equal to 0, we're going to do something a little fancier. We're going to create a method called equalize, just a null method. In equalize, you want to do if speed is less than 0f, which means the character was moving to the left. Then you want to plus equals 1. You want to add 1 to speed. And if speed, or else if speed is greater than 0f, then you want to minus equals 1. You want to subtract 1 from speed. And since this might be a little bit too slow, here I'll just show you right now. It's set to equalize. You must also put Lucas bounds dot x plus equals int speed. Okay. If you play it and you move the character, when he stands, you'll notice he slides a lot when he goes back to regular standing. It's a little unrealistic. It's almost like he's on ice. So we're going to need to change that. If the character wants to stop, he should be able to stop without sliding. So we're going to wrap the equalize in a for loop. So for, first of all, do int I equals, or just int I, right, void equalize int I. That should be good. And up here, change it to 2, put 2 in the method and the arguments, parentheses. Do for int k equals 0, while k is less than I, k plus plus. So this is just going to loop how many times you want it to loop. In this case, we're looping it twice. So now if you move him, when he stops, you'll notice he slides a lot less. He still slides, but just a lot less, so it looks a lot smoother. You also notice if he moves back and forth, he slides like that. You could change that by putting in an equalize. But I'm not going to do that right now, because I kind of like him sliding back and forth. So just look everything over. I'll just make sure I'll make sure that the keyboard one works. It should. Yeah. Okay, so the keyboard one works too. So you've reached the end of this tutorial. If you, I hope you enjoyed it. If you want to check back in the next couple of days for the next tutorial on jumping, which should be a lot shorter, definitely do that. And then I should cover, if this looks like really basic right now, especially by the fact that I didn't even do collision with the ground, I just set its value equal to, his y value equal to something in the beginning of the game. I assure you I am going to change that later. This is just for simplicity in movement. When we have to do jumping on different platforms, then I'm going to have to create a new collision box for the ground and the other platforms. So, thanks for watching, and I'll see you later.